Hi, this video tutorial explains the process of creating and configuring a virtual cluster of grid appliances which can be used for running MPI jobs. I would be using a Debian package of MPI ch2 which will be tailored for grid appliances. For this tutorial, I will create a basic cluster of two nodes, one on my local machine and another on this remote computer. The first step is to have your grid appliance ready. You may download a grid appliance from our website or create one by yourself. On my local system, I will use a downloaded grid appliance. I have already downloaded and extracted one over here. This grid appliance would connect to the default public pool. As it is not recommended to install the MPI package on the default public pool, I will create my own appliance pool. To do this, you have to have your own group VPN and group appliance setup. Follow the links shown below to understand how you can create your own group appliance. To make my grid appliance connect to a private pool, I will need a floppy image which can be generated from the grid appliance website. I will log into the grid appliance website and navigate to the group appliances page. I have already created a group appliance called test_GA. Download a floppy image and extract it. Use this floppy image to replace the one that is there in the grid appliance folder. Once this is done, start the grid appliance. The grid appliance is up and it is connected to my private appliance pool now. Use the command sudo bash to change to the root user. Your password by default will be password itself. Then type the command apt-get update. To install the MPI package, type the command apt-get install grid-appliance-mpi. Installing the package also creates a user called MPI, which will be used to configure the MPI virtual cluster and to run MPI jobs. Switch to the MPI user using the command su-mpi. MPI uses a configuration file called .mpd.conf, which contains a secret word. All nodes in your cluster should have the same secret word. To edit this file, use the command echo and within quotes give mpd_secret word equal to the secret word that you have chosen and redirect it to the file .mpd.conf. This will ensure that there are no free blank spaces or blank lines in the configuration file. Now I will switch over to the remote machine. Here I have a fresh copy of Ubuntu 9.10 virtual machine booted up. I will configure this virtual machine as a grid appliance and then use it as a node on my virtual cluster. I will switch to the root user and add the grid appliances repositories by typing in the following commands. This will allow me to install the packages that are hosted in the grid appliances repository. Now I will proceed with the installation of the base package of grid appliance. It is done using the command apt-get install grid-appliance-base. I need to configure this node to connect to my private appliance pool so that it can communicate with the first node. For this appliance, I will use an internal floppy image instead of an external one. I will mount it as a loop device. I have already downloaded the required floppy image from the website and I have copied it into my virtual machine. To make the grid appliance mount this floppy image every time, copy it to /opt/grid_appliance/etc. After installing the grid appliance base package, it is recommended to restart your virtual machine. The system is rebooted now and it is connected to my appliance pool. Now I will install the MPI package. The command is apt-get install grid-appliance-mpi. As shown for the first node, I need to modify the configuration file .mpd.conf with the same secret word. At this instance, both my grid appliance nodes are running and they have the MPI package installed. To run MPI jobs, you need to bring up a ring of daemon processes called MPD on all nodes. We have provided a script in /opt/grid_appliance/scripts called start_mpd_ring.sh. Run the script and it will discover the other MPI appliances that should belong to your virtual cluster, and it will start the MPD processes on all of them, as you can see in the video. The grid appliance NFS packages can be very helpful in running jobs in the grid appliance virtual cluster. You can install it using apt-get install grid-appliance-nfs and grid-appliance-autofs. These packages are pre-installed in the downloaded grid appliance. Since this appliance has GCC already installed, I do not have to install it again. We have provided some sample MPI programs in the path which is being shown on the screen. These example programs have been taken from a TerraGrid tutorial. To compile a MPI program, use the MPI compiler called MPI-cc. Here, I am saving the compiled program in the NFS export directory, which is /mnt/local. All other nodes in the appliance pool will be able to access this from the directory /mnt/ganfs followed by the hostname of the node which is exporting it. So in this case it is C0050260001 and I can see the executable. This way you need not transfer the compiled program to all nodes which are running it. To run the MPI program, use the command mpi exec followed by the parameter -np In this case, I'm running it on two nodes or two processes. So the parameter is 2 and followed by the path which all nodes can access. This way we have successfully run an MPI job. Hope you found the tutorial helpful. Thank you.